What is going on, guys? Vlad with EEEnthusiast.com here. In today's video, we're going to be looking back at button control in Arduino. So a lot of you have been requesting, and I noticed as well on the Arduino website, that you're having problems sort of controlling the inputs, getting different states through your buttons. Some of you are having trouble just debouncing. So we're going to go over a fairly advanced example of what seems on first really simple, but essentially what I have here, just as a quick demo, I have two buttons with an LED, and the first button, all it's doing is toggling the LED back and forth at full brightness, so I'm doing a full digital write on the pin, and the second one is actually dimming the LED down, and it's cycling through 5 different states. So as I mentioned, a lot of you have been asking questions. How can you, instead of just, reading an input, how can you toggle through different states? And that's exactly what we're going to be going over. So essentially we're going to be doing advanced input and button control for the Arduino. Before we jump in though, I wanted to quickly mention, so there's going to be a couple of links right now on your screen. The first one being to the code for this particular tutorial, which resides on my GitHub page. So feel free to clone, fork that repository, make whatever changes you need. You will find all the code right there. The second thing I wanted to mention is I built a very simple Patreon page. So if you want to support the channel in any way, shape, or form, you are more than welcome to do so. The donations are not going to be required. We're going to be releasing videos on a regular basis regardless, but they do help the production of the channel. So everything is appreciated. Thank you guys, and hopefully you enjoy the video. All right, so let's jump right into the code, and I'm going to be walking you through the entire implementation of this. We're going to be talking some of the critical points that people often miss. First thing I'm doing is essentially declaring that we're going to have 2 inputs. So like I showed you before, 2 buttons, which are going to be on pin 2 and 3 of the Arduino. And then I'm then declaring a couple of other things. So the output pin for the LED is going to be 10. The LED state, which is what I'm going to be toggling, is going to be initialized here. And then I proceed with a couple of variables. You don't need to pay attention to it that much right now, but essentially for every input I have a different state. I am keeping the last input state. I'm also keeping a set of different flags, which I'm going to be explaining later on in the routine. Input counters, so essentially these are just incrementing counters whenever the input is being pressed, again for each and every input, which we have 2 of. The debounce timer, this is going to be used for debouncing the input, as you always should be doing on your buttons and or other inputs. So in the setup function, what I have here is a for loop which goes through all of my inputs. I can essentially increase this to 5, obviously change a couple of other things in this routine, but I can really easily modify this program to, take on 10 buttons, 20 buttons, whatever it might be. So the first thing first, obviously you should all be familiar with this instruction. So the pin mode, whatever pin it is, so it's 2 and 3 in my case, and it's declaring it as an input. This is a very important line, which a lot of you have been asking me questions. So the Arduino has a routine. So essentially, the microcontroller on the Arduino, which is the Atmega 328, has an internal pull-up capability, which is initialized through this digital write. So if you kind of think about this, so you're declaring this pin as an input, but then you're digitally writing to it. You're writing to that same pin a high, which enables the pull-up resistor. And if we look at the data sheet of the Atmega 328, which the reference to which should be on your screen right now, you will see that it has internal pull-up resistors of 20 kilo ohms, which explains why I don't have a single pull-up on my breadboard right now. So for those of you who have been wondering why, first of all, which values to use, 20K is good, 10K is good as well. But second of all, you do not need extra resistors for your builds when it comes to buttons with the Arduino and with this particular microcontroller. So you can enable that with this particular function. Serial.begin, again, to output a couple of values to our screen, no explanations needed. And then last but not least, we're initializing the LED. in our loop function, so what I've done is essentially separated the different segments of the program into three different sort of major categories. So we set the input flags, which is essentially we get the button presses into our flags and kind of make sure that we do flag the input when it is being toggled. Then we resolve the input flags, so we take care of the logic on the Arduino itself, and then we resolve the outputs, which means that we, based on whatever logic we've calculated in this routine, we are gonna toggle the outputs. So let's take a look at the set input flags routine. So in case you haven't seen already, or you had some difficulty with the debouncing routines for your programs, I'm not going to go too much into detail as to why you need to debounce. I've made a couple of videos on that before. The links are going to be on your screen right now, but essentially this is the debounce routine that you can find in the file and in your examples of the Arduino program, and it's fairly straightforward, but let's go over it just kind of for experience. So my for loop is essentially just cycling through all of my inputs. If you have more than one, then you're gonna have to go through, checking every single input one by one to make sure that you do capture all of them. Reading, right? So we're doing a digital read on the output, so it's either high or low depending on if it's pressed or not. Also, you need to pay attention to the fact that my buttons are in a normal unpressed state, they are being pulled high, and when I press the button, it's being pulled low. So depending on what you're expecting in your circuit, you should be kind of thinking about that. So if the reading is not equal to the last one, right? So if our current reading is different than as we press the button, we are gonna store the milliseconds that the timer is on the Arduino into a register. And again, I'm going to be referencing this on the screen, but essentially what this returns is the number of milliseconds since the initialization of the Arduino, which is extremely important in placing timestamps on your different inputs. All right, so the next, if the millis, so that means enough time has passed between the current time and the last debounce time that we've stored right here. So if the button has been pressed for enough time, or more time than the debounce delay, which was 50 if we refer back to the above. So if 50 milliseconds have passed since the last time that the output was toggled, and if the reading is not equal to the input state, right? So if the button is still on the grounded state, right? If it's still grounded for 50 milliseconds, we need to record the reading. And if this input state is high, so once the button is released, so think of it like this. We are recording the time, and if the time has passed of more than 50 milliseconds, and when we release the button, we are going to set our flags. So the flag for that particular input is gonna go to high, and if you scroll back up, it's initialized to low at the beginning, just to make sure that we do capture it, right? So think of it like this. Again, let me walk you through this. So as I press the button, if for example, if the button bounces within that 50 milliseconds, it is not gonna go and record this last time. It is not gonna calculate this last debounce time. So it will bounce until at least 50 milliseconds of straight ground have been detected. And once you release the button, we set our flag, right? So this is extremely important. And then we just update the last input state so we can keep on toggling the button. So the first question that comes to mind is, why do you care about these flags? Well, the flags are a very interesting feature which allow you to essentially have as many inputs as you want, and you can record them regardless of the other ones. So in very simple terms, what this means is if you were to implement this function with delays or with like wait functions, so for example, if you say like wait for this to be high, then you would be essentially bound to a single button. But in this case, as soon as you press the button, you're already in this routine. You're sitting in the routine and you're waiting regardless of the other buttons. So let me really quickly demonstrate this to you. So even though I have the second button pressed, I'm still recording the inputs from the first button. And once I release the second button, the flag gets executed for that particular input. So essentially, it's not locking up your program. It's kind of pseudo multi-threaded programming, so to speak, on your microcontroller, that you flag your input, but you're still monitoring all of your other, like the program doesn't lock up, it keeps on monitoring. So this is extremely useful for any of your sensors, any of your inputs, essentially. The next routine, if you remember scrolling really quickly back up, is resolve the input flags. So right now, flags are either high or low, correct? There's no kind of in between. They're just a simple Boolean, so they can only be high or low. So we're going through all of the inputs, and if the flag for that particular input is high, we execute a set of logic. If it's low, this whole routine just doesn't do anything, right? So if the flag has not been set, this entire routine just simply does nothing. So let's think about this. There's a couple of things that we need to address. So if the flag is high, first of all, we count how many times the button has been pressed. So all I'm doing is updating an input counter. Very simple. You've seen it on top here. Input counter for each and every input. We have that right there. The second thing is what we're doing is we're updating the LED state. So updating the LED state is a function which essentially, so the LED state, let's scroll back up. The LED state is an integer which is initially set to 0, but as the flag gets toggled, we update the LED state, but we're also passing a variable which is our I that we create in this for loop, so that it knows which input has been pressed. So depending on we're gonna see it in that function in just a second, but depending on which input, which button has been pressed, we do a different update on the LED. And as I've mentioned to you earlier, the first one is just doing this toggling back and forth. The other one is changing the brightness, right? So we do have to differentiate between the buttons. What else? So let's jump into this routine really quickly. All right, so the update LED state routine, which it takes the input as the argument. So if the input is 0, which means it is this button, right? So if we can have either input 0 or 1, since we have only 2 buttons. So the input is 0. What we're doing is toggling between a 0 and 1. What we need to account though for is that if the LED state is 0, right? So imagine the LED state can either be 0 or something else. So if it's 0, we're going to toggle to a 1. But if it is something else, because we're still toggling the LED state with the other button, we're going to bring it back to a 0, right? So every single time, if you're playing with the second button, right? So the brightness is at some random level, we want to bring this back to a 0. Followed by that, we can toggle between a 0 and 1. And then depends on your functionality. You can do it in a different way. You can keep that state and kind of toggle in between regardless, but I'd like to bring it back to a 0 state the first time a different button is pressed. Else if, right? So we don't want to make this as an else because we can add different inputs in the future, but if the input is equal to 1, so that means if I'm pressing the first button, what we're going to do is essentially cycle through 5 different states of the LEDs. But the way I've done this is actually really interesting, right? So let me just quickly put some comments in here. So for input 0, we have state 0 and 1, right? So in your first button, all you're doing is toggling state 0 and state 1, so to speak. But for input 1, you're toggling states 2 to 6. Right? So imagine it like this. So imagine that my LED state can go from 0 to 6, right? Greater than 5. So here's what needs to happen. So first of all, if the input is 1, right? So if this is the button that's being pressed, if the LED state is 0 or 1, meaning that this is what has been controlled by this button, right? 0 or 1, or the LED state is greater than 5, right? So we've essentially gone through all of these cycles. We're at 6. We want to bring the LED state back to 2. So it's essentially a cyclical loop, right? So if the input 1 is being pressed, right? So we're gonna make our LED state equal 2, 3, 4, 5, 6, and then it's gonna be again 2, 3, 4, 5, 6. And etc. Right? So it's gonna essentially cycle through those states. And you can this is a question that came up very, very many times. How can you set, a predefined number of sets for your buttons and execute them one by one? Well, this is exactly how you do it, right? If it's greater than 5, then you can cycle back to your initial state, and you don't need this. You can have this like one button, and you can have like different 5 states. In my case, I have 7, 2 of which are controlled by the first button, and 5 of which are controlled by the second button. And you can add more. You can say that if it's greater than 5, then this one cycles, and then you have another button that essentially continues on the cycle and goes like 7 through 10, for example, 4 different states. In any case, coming back really quickly to the logic, we set to 2 at the beginning, otherwise we're going to cycle. So LED state plus plus. Pretty simple. So let's come back to the to our main resolve input flags function. So here we have the print string functionality, which is essentially, I'm going to be showing you this in a second, but it's outputting, which input has been pressed, the counters, and the number of times that it has been pressed. So pretty simple output function. So let's take a look at that really quickly. All right, so let's take a look at the serial monitor, which is essentially just displaying the counter for each and every button. So this is my button 0, this is my button 1. And as you can see, it's a very simple counter, but it's always debounced. Everything's really nice and smooth. Like I've mentioned earlier, if I do hold down one of the buttons and keep on pressing the other one, because of that flag routine, we do not lose any of the inputs. We're not waiting for anything. There's absolutely no kind of interference between the two. You can play with these inputs as many times as you want. There's no lockups in the program. So very, very important to implement your inputs as such. If you have them, for example, on a mission critical project, such as a sumo bot, for example, you always want to detect, as soon as possible, but you also don't want to lock things up. So you want to keep going through your inputs, keep reading them, and sort of seeing that as they scroll through. But essentially very simple serial print for all of our counters. What do we have next? Let's scroll back up, and now we have input flags. So obviously, if the input flags have been set to high, we've processed them in our function. We want to set them back to low, right? Because we've already taken care of the logic, and we don't need to do that anymore. We're going to be waiting for the next button press. So very, very simple to implement, yet very intricate routine that you guys need to be aware of. The next step is going to be resolve outputs. So now that we have all of the counters, all of the variables that we essentially need, all of our logic has been processed, we need to figure out what do we do with the outputs, right? And this is, it is very important to kind of split up your code into these segments, because that way it becomes very modular, right? So right now I can rewrite this routine, but I don't really care about like my LED doesn't care about the state of my logic. All it cares about is the final output that it receives. So essentially, like, we can decouple these pieces of code and use them in separate routines, you know what I mean? So like I can take this and use this on like 10 LEDs for all I care in a different program. I don't need to rewrite this anymore. But anyways, let's scroll back down through our resolve outputs. So this is, again, I only have one LED on here, but you can have, different cases for whatever states you choose to update in your logic. But as I mentioned before, what we have is different cases for the LED state, a total of 7. So 0 through 6. And we need to take care of them with a I'm doing it with a very simple switch statement. You can do it with ifs, else ifs if you want to, but going through the switch LED state. So if case is 0, like I've mentioned, or 1, we're switching between low and high, right? So if that state, if the button toggles that state from 0 to 1, we're going to be doing a low or a high. If the state is between 2 and 6, I've chosen, honestly, arbitrary values for the output, which are 30, 70, 100, 155, and a full 255. And notice that we're doing a digital write or an analog write on the same pin. So you're not restricted. The Arduino doesn't restrict you to using, if you put on LED, then you don't need to write one or the other. So it's very simple to kind of switch up your routine and do very, very intricate things in such a way. Like I mentioned before, you can expand this to multiple cases. You can expand this to multiple LEDs. You can have, LED 2 state. You can make this an array. So you can expand this as much as possible. And yeah, so guys, this is pretty much the entire code. It will be available, like I mentioned, on GitHub. So feel free to, take the code, reuse it in whatever way you need. Make sure to leave me some comments in the section down below. Make sure to like the video if this is the kind of stuff that you're interested in, or make sure to leave suggestions. Like I've mentioned on the other video, I'm taking note of some of your suggestions. I know you guys want some more advanced stuff at the same time. Some of you want software, hardware, so keep them posted. I'm going to be making more videos, so stay tuned. And if you want to contribute, there's the Patreon link at the bottom as well. Anyways, see you guys in the next video. Take care. Bye.